Okay, so we left off last Thursday talking about triangles that had no right angles, oblique triangles. While I am thinking about it, by the way, next week, Monday, I'm taking my personal day, so it will not be math class next month.
What are you doing next Monday?
What's that?
What are you doing next Monday?
I'm just extending my Easter holiday. It's been years since I've actually used up all my personal time, so I'm gonna try to use a little bit of
Carry over.
it. No.
Get a
It
couple
doesn't carry
hours.
over.
Get a couple exogences over to
Well, and for like sick time, we can only keep up to 840 hours from one year to the next. Since I've been here, I've lost almost 800 hours of sick time because I haven't taken it.
Wow.
Yeah, it's a little silly. So anyway, oblique triangles. We had a couple of different cases that we had. And I'm actually, rather than draw the triangles, I'm going to give you the information. So if I have angle A, angle C, 7 degrees, and it's side A, is there anything here that I need to worry about as far as not being able to make a triangle or having two possibilities of a triangle or anything like that? Here, I have two angles, right? Well, if I have two angles, I really have all three. How can I find that third angle? There you go. Add them up, subtract them from 180. 67 plus 32 is 139. Nope, not 130. 118 is. Subtract, we get 61 degrees. But B is 61 degrees. So really, we have all three angles. We haven't done any trim. So there is no ambiguous case here. There's only one triangle this can form. We don't have to worry about any of those other possibilities. So we're going to jump right in and find our missing pieces. Now, what's the one thing we need in order to start our lost sides? Side and size of the corresponding of the opposite angle. Here we have that for A. We have side A and we have angle A. So it'll be 19 inches is side A. Sine of angle A is 52 degrees. You guys pick, which side do we want to find first, B or C? B goes on top because that's a side, just like the 19 inches. What's going to go below it? Sine of what? 61 is the angle that corresponds with B. Cross, multiply, and divide. 19 times 1. Close that parentheses. Divided by the sign. 22. 21.09. Side B. Now, when we think about it, does that make sense compared to side A? A little bit bigger than 19. Do the angles match up? Yeah, it's a little bit bigger than 52 degrees. Longer side is still with the larger angle. Find side C. Where do we start? Yep, we'll stick with the 19 inches over the sine of 52 degrees. For side C goes on top, what goes below it? Find C, we're going to cross, multiply, and divide. 19 times sine of 67. Make sure you close that parentheses. Divided by the sine. 0.19. 23.19 inches. So as we check here, is our shortest side across from our smallest angle? It is. Is our longest side across from our largest angle? It is. Anytime you're given two of the angles and one of the sides, you're safe. The worry comes when we're only given one angle and two sides. If I am given that angle C is 38 degrees, side C is 42 inches, and side A 29 inches. Do I have anything to worry about here? Do I have to worry about, do I need more information? Sometimes you need more information when you have two sides and an angle. Remember, we compare the size of the angle of the side that is opposite our given angle. Here, that would be the 42, right? Is it bigger or smaller than the other side that's given? Bigger. It's bigger. When the side that's opposite our angle is the bigger side, we have no worries. We're good. So we can find side A here, or angle A here, straight on. We're going to put the 42 inches over the sine. Nine inches over the sine of 38. The reason this is safe is because this side is smaller. So what does that tell us about angle A? It has to be smaller. So we know angle A has to be smaller than 38 degrees, which means we know it's acute. So we don't have to worry about being obtuse or acute, right? So we cross multiply and divide here. Sine of 38 times 29 divided by the 42. Sine of 38 goes in parentheses times 29 divided by 42, sorry. 42. We get 0.4251. What else do we need to do here? First sine, good. So the calculator is going to do second sine and second answer so that we keep it in the calculator. We get 25.16 degrees. How do we find angle B now?
Add the angles together.
Perfect. 38 plus 25.16 is 63.16, right? You subtract that from 180, giving us, what is that, 116.84?
Yeah.
116.84 degrees. And to find side B, well, we go back to our 42 inches over the sine of 38 degrees, over the sine of 116.84. Now, I've told you before, we always try to go back to original information. When we get into these problems, there's going to be at least one piece where we have to use something we've already calculated. So we can cross multiply and divide. Here it'll be 42 times the sine, 116.84, close the parentheses, divided by the sine of 38 degrees, giving us 60.87 side B. Inches. So let's double check. Is our smallest side across from our smallest angle?
Yep.
Yes. Largest side across from our largest angle.
Yep.
Now when you have an obtuse angle like this, there's another check you should do. Are the two smallest sides, if I add them together, are they bigger than the largest side?
Yep.
Yes, they are. 29 plus 42 is 71. That's bigger than 60. Just a couple of simple checks you can do just to make sure your triangle makes sense. Because if that third side was longer than the other two added together, those other two wouldn't reach each other, would they? There's no way it could be a triangle. The situation that we had to worry about was this one. Angle B, 29 degrees. Side B, 18. And side C is 35. What about this problem? What do we see about this problem that alerts us that we've got to have one more little piece of information? Going in the right direction, yes. The side that is opposite our angle that's given is smaller than the other side. The longer side is not opposite the angle. This is telling us that we could, if we could draw two possible triangles here. This could be side C of 35 feet. Angle B, 29 degrees. This could look like this. 18 feet. Or this. 18. So, what's happening here is this opposite angle here could be acute or it could be obtuse. Angle C could be acute like this, or angle C could be obtuse like that one. So we need to know whether angle C is acute or obtuse. Just for the sake of the experience, I want to tell you it's obtuse. So we still have a side at its opposite angle. We still have the 18 feet, and it is opposite the 29-degree side. The only other piece of information I have is 5 feet. That has to go on top because it's the length of a side. What's going to go below it?
C.
Sine of C. Cross multiply and divide here to get the sine of C. So the sine of 29, close parentheses, times 35 divided by 18 gives us 0.9427. What's next?
Inverse.
First sine, good. 0.9427 gives us 70.51 degrees, yep. Is that my answer? Say no.
No,
Why not?
because
Because C is obtuse. 70 is not obtuse, is it? Actually find C. Remember on our unit circle, there's this angle over here that had that sign, but there's an angle over here that has the same sign. That's the supplement of the 70. So we have to subtract the 70.51 from 180 to get 109.49 degrees. Angle C is 109.49 degrees.
so you just subtract the difference from 180.
Subtract it from 180, yes. If you know the angle is obtuse, once you do the inverse sine, the angle that you get with that calculation has to be subtracted from 180 to get the actual angle.
So it keeps just stepping out that last part.
Yeah. Two angles will be supplements. They will have the same sign.
So if you said that C was acute, then
So it just would have been 70.51. We had said that was acute. Now we can find A by doing 180 and subtracting 29 plus 109, 49, which is, what is that, 138.49. Subtract that out, gives us 41.51. Now how do we find side A?
times A over the sine of 41.51.
Perfect. A over the sine of 41.51. Had to find that other angle to find that last side. Now we're going to cross multiply and divide here. 18 times sine 41. Close the parentheses, divided by the sine, 9, gives us 24.61. Not so bad. So this is a big deal. At angles of obtuse, you have to subtract what you get from your calculation when you do the inverse sine. You have to subtract 180 to get the obtuse. Most of the time, you can see it in the picture, or you're told that it's an obtuse angle. Where it gets to be difficult is if it's like 92 or 88 degrees, where it's right close to 90 degrees. It's a little bit on one side or the other. Then it's a little tougher to work with. There was another case that gave us a problem, and again, it was one where we had only one angle and two sides. Something like this. I told you that angle A, 49 degrees. I did not know angles B or C. I told you that side B, 29 feet. Side B, C, 37 feet. We do not know side A. To law sines, we have to know what combination. We have to know at least one side length and its the size of its opposite angle. We don't have that here, do we? I draw this out. ABC, little a, little b, little c. Obviously not drawn to scale. If angle A is 49 degrees, side B is 29 feet, and side C is 37 feet. Definitely not drawn to scale. Yeah, there's no side in its opposite angle there. What we have to apply is something called the law of cosine. Now, to make this formula work a little easier for you, I'm going to draw a new triangle down here. For information, just because it's easier. So I have my sides, and my angles, ABC, little a, little b, little c. I give you 57 degrees for side C, for angle C. Side A, I'm going to give you 42 feet. Side B, I'm going to give you 48 feet. Law of cosines tells us that the length of side C squared, side A squared. That looks kind of familiar so far, doesn't it? What's it look like? Pythagorean theorem. The law of cosines is sometimes referred to as the generalized Pythagorean theorem. Pythagorean theorem only works for right triangles. Law of cosines generalizes it for triangles that are not right angles. Adjustment factor is minus 2 times the length of side A times the length of side B times the cosine of angle C. Now, I typically will shorten this up a little bit, but for right now we'll keep it together. So our side A is 42, that's 42 feet. Side B is 48, so that's 48 feet. Take the feet off it just so I don't confuse it. Kind of looks like it's to the power of 12 if I leave it. Minus 2 times 42 times 48 times cosine of 57 degrees. This part right here, I can actually type in all at once. I'm going to go ahead and do it. 48 squared minus 2 times 42 times 48 times the cosine of 57. Notice I typed that all in without ever hitting equals. That is the best way to do it because there's only a couple of spots here where you can hit the enter or equals key and not screw up the calculation. So it's best to put the whole thing in all at once. I get 1872.02. Now that is C squared. How do I get C? Notice again, I did not clear my calculator, so I'm just going to do second square root. Previous answer, 43.27. 42.27 feet. Now, I can find my other angles, because now I have a side angle opposite it. So now we can go back to using just the law of sines. Question is, which angle do we want to find first, A or B? Now you ask the question, does it really matter? And the answer is, it really kind of does. Well, careful.
It's
50-50
50-50
shot, right? Can anybody think of a reason why we would rather find A first here? Opposite the shorter side. There can only be one obtuse angle in a triangle, right? It would have to be opposite the longest side. So if there is an obtuse angle in this triangle, it would be angle B. Now we don't know if it's obtuse or not. It's really kind of close, isn't it? Picture. We don't know, so to play it safe, we always want to use the shorter side and find the angle opposite that shorter side, because we know that one has to be acute, because you can't have two obtuse angles. So we will set this up. It's going to be the 43.27 feet over the sine of 57 degrees equals, we use the 42 feet over the sine of A. And we will cross, multiply, and divide. Sine of 57, close parentheses, 42 divided by 43.7 gives us 0.8141 for the sine of A. What's next? First sine of that answer, 54.59 degrees. We know that that is the actual angle. We don't have to worry about subtracting from 180 or anything like that, because A has to be the smallest angle in the triangle because it's opposite the smallest side. Now how do we find angle B? Yeah, we'll add those together. 57 plus 54.59 is 111.59. And then 180. Could have got there eventually.
I'll take it too.
Yep, that's what I figured. That's 68.41 degrees. We have it. All done. Not so bad.
No, let's not go back to the.
I want to go back to the law of sines.
Nah.
Oh, come on. Go ahead and try one of your notes. I'll give you the angle E is 51 degrees. I'm gonna give you side A up here. And side B down here is, oh, let's go 30. Find side C, angle A, angle B for me. Couple minutes. Write the formula down. Take a look. We're gonna find side C here, so C squared equals, what goes in next?
3 squared.
3 squared
Plus
plus
31.
1 squared minus 2 times
63.
63 times
31.
31 times sine of 51 degrees. So I'm gonna punch that all in. 3 squared minus 2 times 63 times 31 times the cosine of 51. 2471.87. Now I stress, do not hit equals. Do that, type that whole thing in at once. A lot of people want to hit equals before they do the cosine. That will totally screw up your calculation. Just type in that whole line into your calculator all at once. It's the easiest way to do it. Best way to avoid a mistake. Now we do have to do the square root of that. 49.72. How many had 49.72 for C?
49.
7, 8?
Yeah,
You wrote it down and typed it back in.
yeah. Probably.
That's within acceptable tolerances. If you're within a few hundreds, I'm good with that.
I even wrote down to 7 digits after the decimal.
Really?
Yeah.
You might have missed the 1. 7179, you might have skipped that. You just said, very possible.
Well, the first part of it, you get 4,930, and the second part of it, you get 2,458.1254474, and I subtracted those two.
You were close enough. I'll give you that. Now I'm going to give you guys a minute to find angle A and B here quick.
Yeah, those might be a little off.
Just a touch. It'll still be right.
Oh, you know what? I would have had 49 myself. But I would have had 49 books.
Now, to find our angles A and B, which angle do we want first, A or B? B. Why do we want to find angle B first?
To see if A is
Yeah, because we know B is acute because it's opposite the smaller of the two sides.
It ended up coming out the same for the angles, or pretty damn
It
close.
doesn't. Yeah, the sides have to be significant.
Yeah, because it was, I had 34.4, something, I had 34.43, so, but I still wrote down 34.4.
So to find angle B here, we have the 49.72 over the sine of 51. Then we use the 31 over the sine of angle B. So now we're going to cross multiply and divide to get the sine of angle B. The sine of 51, close the parentheses, times 31 divided by 49.7. 4845. 4845 is the sine of angle B. And then, of course, we have to do what? Sine of that answer, 28.98. Now to find angle A, I have to add together 51 plus 28.98.
It was
29.98, thank you. $51 plus 29 is 80.98, is that correct? Let's subtract that from 81 or 180. 99.02 degrees is angle A. Angle A is obtuse, but we would not have known that for sure if we had found that one first. What do you think? Great stuff? You're funny.
My father.
Now, when we look at this example here, one issue. Formula is it's still two sides and the angle in between them, but the angle is not angle C, is it? What I do? I'm going to relabel this so this is angle C, which means I have to relabel this probably as angle A. I have to change the sides, so this will be side C and this will be side A. Now my angle is angle C, and I'm trying to find side C.
So you couldn't just do A2 equals C2.
Well, you could have.
Then
You just have to keep
minus
track of the
280.
formula, you know what I mean?
Then you just replace one with the other all the way.
Just replace A and C. You could have just done that too. Switch A and C here, so this would have been angle A, side C, side C, side A. If that's fine, if you're good at doing that, that's actually probably a better way of doing it.
So the 2AB would be 2BC then.
Yes. So here, it's going to be 27 squared plus 41 squared minus 2 times 27 times 41 times the cosine of 60 degrees. Yeah, if you're okay with switching the letters like that, you're going to come up with the same formula. Usually it would be A squared equals that. Yeah, you'll get the same number. Now I am going to do this. I am going to do just C instead of C squared. I'm going to put a square root around it. So when I enter this, rather than just entering that whole line, I'm going to do the square root of first. Then 27 squared plus 41 squared minus 2 times 27 times 41 times the cosine of 63 degrees. And I close the cosine and I close the square root at 37.48. The reason I did that example there is a lot of people mess that up because they don't forget to put two parentheses at the end of it. You got to do a parentheses to close your cosine, then you have to do a parentheses to close your square root. That works. If you can remember that, this is a lot easier way of doing it. You can do it all in one line. You don't have to go back and do the square root again later. 7.48. Now, that's really not side C, is it? It's really side A. Back and put the original labels back in. I just changed the labels so I could do my log cosines without having to rearrange it. Now, which one do I want to find first? Angle B or angle C? B. On the smaller side. So I now have my 37.48 feet over the sine of 3 equals, which side am I going to use? 7 over the sine of 37 will be across from 6. So we're going to cross multiply and divide here. Minus 63. 7 divided by 8. 419. 10. Per sine. 39.93 is what I get. 39. 93 degrees. Add together the 63 and the 39.93. You get 102.93 degrees. And back from 180. Good. 77.07 degrees. And I think we can find side B now using going back to our law of sines, right? Good with that? I'll make you guys do an example where the sides are not that. So I'm going to give you that this side here, angle here is 42 degrees. That's angle A. Side B, 3 feet. Side C, let's call it 40. Find the two missing angles. An angle B and missing side A. Give you a few minutes. Find our missing side A. A is gonna equal, of course, I'll put in the big square root here. What goes on the other side over here? Squared plus 83 squared. And root 82 squared. Cosine of 42. 56.38.
Yes.
Any questions on how I got that? Now, obviously, I want to find which angle next. Equals opposite the smaller side. 56.38 sine of 42 degrees. Cross multiply and divide. Sine of 42, close parentheses, times 52. 56.38. Give me 41.78. Now what did I do wrong? Oh, I put in the sine. Sine of 42 times 52 divided by 56.38. No sine. That did come out a little different. 0.6141. Then sine 0.6141. Second sine, second answer, we're at 38.11 degrees. From that, I'm just going to go ahead and do it the short way. 180 minus 38.11 minus 42, 99.89 degrees. Once again, B would have been is obtuse. There's a third possibility. Remember we said the only combination of three pieces that we could not use to solve for the missing piece of the triangle is if we had all three angles. But what if we have all three sides? So if I tell you here that side C, or side A is 42 feet, side B is 51 feet, and side C is 47 feet. We can find one of our angles. Now I'm going to pick an angle to find. And I'm just going to pick angles. Or find that angle. Have this formula here. Right? We know side C, side A, side B. We just don't know the angle C, right? So we can rearrange this formula here. I can subtract both A squared and B squared. Squared minus A squared minus B squared. That is all then gonna be divided by a negative 2AB. That would equal the cosine of angle C, right? Sense? Now I'm leaving it like this for now. Because what we're gonna do is we're gonna do the top up here first. This is where we do want to hit equals now. We're gonna hit equals before we divide. So we're gonna do, put in our number, C squared will be 47 squared. Minus A will be 42 squared. Minus B will be 51 squared. All over negative 2 times 42 times 1. Let's do this piece right here. So we either enter the top, then enter the bottom, and then divide them. Probably the easiest way to do it. 47 squared minus 42 squared minus 51 squared. Now this is typically going to give us a negative number here. Negative 2,156. Which is okay because on bottom, we're definitely going to get a negative number. Negative 2 or 2 times 1. Negative 4284. What would be next? Well, we could divide it out, but we can actually do it all together with the inverse cosine. First, and cosine. Negative 2156 divided by negative 4284. Close that parenthesis. Right, 59.78 degrees. So this formula right here is a handy version of the law of cosines to have down. Actually, it's this one up here would be one of the variables in it. C squared minus A squared minus B squared over negative 2 times A times B. Now, of course, once we have this one angle here, we can find the other angles just using the law of sine. So we're not going to worry about going back and finding those. So let's say that I tell you that this is 3 feet. Over here is going to be 9 feet, and B is. Try to find angle C for me in your notes.
got 131.
Yeah, that's. Top of our fraction will be the 49 squared minus the 43 squared minus 65. Here's a negative 3670. The bottom is going to be negative 2 times 43 times 6. That's negative 5590. That equals the cosine of C. Now, I'm actually going to drop the negatives. We know a negative divided by a negative is a positive, right? I'm not even going to waste the time putting in both those negatives. Inverse cosine of 3673 divided by 5590 equals C. Is 86.24 degrees.
I get that either of the 3 times I tried. Maybe if I average all 3 of my answers, I would get that, but. Can you do 3673 divided by 5590 and then equal that and I get the close?
Just be able to.
Well, I tried that.
Those are the same two numbers you had, the 3673 and the 5590?
Yep. The one time I tried, I got 130, 131. Now I got.
Oh, this is not the correct answer, by the way. Numbers did not enter into my calculator correctly. One number's missing. So let's 73. 48.92 look better?
I did have that one. On my last try.
I got. I don't know if I'm just typing that in wrong on my calculator on my phone, but it comes up to a decimal and not a.
You have to click enter then, after usually.
Yeah, I do the. Like, cause I got 3673 over.
5590.
Yeah.
On most of your cell phones, you have to do that division first, and then you've got to hit the second cosine, or inverse cosine.
Oh, really?
Yes.
Yeah.
Especially if you're using the standard Android scientific calculator.
Yeah.
It works backwards, yes.
I wish they would make an update where you can take both the whole. Okay, that'd be nice.
Well, since it's about that time, big book, page 908, 909.
Oh, I got it.
Did you?
You have to work? Good. Exercise 36. Oops. That's the wrong page. That's wrong sheet. Let me get the right page down here for you. It's page 916, 917. Exercise 36-6.
First time I did it, I got.
And page 920 through 922. Exercise 36-7. That is the problem with these, is we're now getting into problems that have so many steps to them. And we've got 6 more weeks to make them worse, just bracing you. You know, one mistake in one step, and the rest of the problem is done. So
You guys want to find where you live?
I admit totally that these are tough. And after this next test, everything we do in here is going to be a group. So I'm going to expect you guys to be sitting down somewhere on a quiz working together on.
Well, how about Mondays? Mondays from about 9:30 to 11:30.
Get out of Scott's class.
Yeah. I'm gonna go in there right now and just draw my thing for 4 hours and be done. Well,
Well, you guys have a great day. We'll see you all later.
yeah, you're right.